Hello guys, welcome back to a new video. And in today's video we have got an important topic of physics, that is momentum. Momentum is kind of a important topic and very basic topic of physics. So let's get into it. And there is a diagram. You can see there is a formula written over here: P is equal to m into v. So first of all we get to know this P over here is momentum. P is the symbol of momentum is termed as P, and that is equal to the momentum is equal to the product of mass and velocity. So we'll be understanding uh, this diagram or this formula. First of all, let's look into the basic definitions on all that stuff. So momentum, as the formula is written over here, we simply write the definition of momentum as the product of mass and velocity. The product of mass and velocity is called momentum. Okay, so this is just the formula definition. We can see that P is equal to m into v. So this is just that is a mathematical form, while this is a statement form. So what is momentum in reality? First of all, uh, let me tell you a point that momentum symbol here, I'm including a point symbol, so you can write it in your notes like we are denoting momentum with the symbol P. Now let's get more into it. The product of mass and velocity is called momentum, and what actually this product is showing, what actually mass into velocity is showing, what momentum is showing. So momentum is basically the quantity of the motion is called momentum. Quantity of motion in a body is called momentum, right? Uh, the the product of mass and velocity will give us some sort of value, and that value will show the amount of motion in that body. So this is kind of interesting, right? And yes, uh, of course, if we are determining the here we are seeing, like, if we are determining the quantity of motion. So in the quantity of motion we have a body. For suppose this is you, and I want to determine motion in you. So I want to look into two factors. First of all, your mass m, that is playing role, and the second, the speed which you are moving, that is velocity v. You're moving on this road, right? So there would be two factors affecting the mass and velocity. So there are velocity and mass. So here we have taken the product of mass and velocity. This is the reason. And yes, let's look into the formula. P is equal to m into v. M into v, right? And this is a vector quantity, like here we have got the velocity in it, so this is kind of a vector quantity. It is a common sense, like we have got velocity in the formula, so it is vector. And momentum cannot be non-directional, right? And if we decode the formula, so we get the unit. So a unit would be equal to the mass is kg, kilogram, and velocity is meter per second. So this is a unit. Kilogram meter per second is a unit, the SI unit of the momentum. Now let's look into some other points. uh, you know Momentum also is, if the velocity of the body is zero, the momentum is also zero. So momentum and velocity are directly proportional, and in a body the direction of the momentum and the velocity are same, and they are parallel to each other. Now let's look into new sort of concept, which will give you a new sort of formula that is also very important. So yes, if we do see here, and if we use here using Newton second law of motion, law of motion. Now what does it says? Like we have seen that the Newton's second law showed us a formula that the second law showed us the quantity of a motion. So that was like this: F is equal to ma. So we can link these both terms as well. F is equal to ma. So uh, if you decode the a, you will get F is equal to m, and the acceleration is equal to delta v upon t. That is equal to final velocity minus initial velocity, vf minus vi upon t. Right, this is a term, vi upon t. Right. So uh, what you're gonna do is this: what will happen if you multiply these terms? F is equal to uh, mvf minus mvi upon t. Right. This is you're gonna see, you have noticed this thing, that this is a formula of the momentum. So that would be directed to this. Like you can say that F is equal to uh, pvf, sorry, the pf, the final momentum, because m into v is equal to momentum. So we have got final velocity, so we have got final momentum minus initial momentum upon time. Right. So here we have got a final statement that force is equal to change in momentum, because we have seen that delta v is equal to vf minus vi. So same in condition, we're gonna say that uh, delta p vf minus the pf minus p is equal to delta p, that is upon t. So this is the final term that we have got, and this is kind of very important equation, and this statement tells a lot. uh, Here we have got the force formula, and we have got also delta p. If you want to find delta p, the change in momentum, you're gonna put the formula and you will get f into t. F into t. Right. This is also very important. This is also important, right, to mention it. Now uh, we've got a new definition. If you're gonna see here, yeah, I hope that you've assumed like uh, the force is equal to change in momentum, uh, momentum per unit time. The force, or in other words, let me tell you a tricky statement that will help you. The rate of change in momentum per unit time is called force. Now this is a new definition of the force, and that will help you shortly. Okay, so here we have seen a new definition of the force, and yes, this shows that the force and momentum are directly proportional, and a rest body has zero momentum. Now in the next video we're looking into the impulse concept, because these topics are quite similar, and that may confuse you. Like, what is impulse? Impulse is also the rate of change in momentum, while if you're gonna see this formula, delta p is equal to f into t. So how will you determine the both, like the momentum and the force formula, or the delta p is equal to f into t, and the delta p is equal to pf minus vi? So what's the difference between those? We're looking into the next video, the physics series. So meet you guys in the next video. Till that, goodbye.